Interpreting simulation results, tornado graphs. The idea of using tornado graphs is to perform sensitivity analysis. A tornado graph will display a ranking of the input distributions that impact a certain output. Those inputs with the largest impact on the distribution of the output have the longest and topmost bars in the graph. A tornado graph for an output can be displayed by selecting a row or rows in the results summary window, or by clicking the tornado graph icon at the bottom of the window and selecting one of the tornado graph options. 76. Alternatively, click the tornado graph icon for the displayed histogram for total cost on cell K21. You can observe that the simulated output can be changed to a tornado graph by clicking and selecting a tornado graph. At risk, we'll select a list of 5 different types of tornado graphs and 1 spider graph. We will explain all of these tornado charts later on with detail. For now, we will select the first one, tornado change in output mean, as our starting point. The following chart appears. Observe the names of the bars at the left-hand side of the chart. The first 2 bars exactly repeat themselves, weather-related delays. The third line of activity 4/simulated unit price seems to repeat itself along the 7th line, also related to activity 4/simulated quantity. The 4th and 5th lines for subcontractors go out of business also repeat themselves. At this point, this tornado carries along at least 2 types of errors. It repeats information on bars for various input variables and has somehow split each one of the activities into its 2 components of unit price and quantity, where it would be desirable to have somehow integrated for each activity the synthesized integration of unit price times quantity altogether. Keep in mind that tornado charts show the relative importance that inputs have upon a certain output. 77. Considering this, click on the Simulation Settings button and go to the 3rd tab, Sampling, to change one particular setting there. On the bottom part of Other Options, change the Smart Sensitivity Analysis option to Enable. 78. Close this window and now run a simulation with 10,000 iterations. Smart Sensitivity Analysis is a function that pre-screens inputs based on their precedence in formulas for outputs. Inputs that are not linked through the model's formulas to an output cell are removed from the sensitivity analysis. This avoids inserting spurious results into a tornado graph interpretation. Smart sensitivity analysis is performed because it is possible for simulation data to show a correlation between an input and an output when, in reality, the input has no effect on the output in the model. This is what spurious means. If smart sensitivity analysis is disabled, then the tornado graph bars could be displayed for those unrelated or spurious inputs. 79. After the simulation has finished, click on the Browse Results button again to view the previously created tornado graph. This is what will be shown. Observe that the first error detected, related to the duplication of lines for event risks, has ceased. This has been solved by smart sensitivity analysis that somehow detected that the embedded functions within the compound distributions were not actually separated effects, but somehow integrated them together. An error persists with respect to the integration of activities by unit prices and quantities. We will deal with this next.